We want to prove that we can draw a perpendicular line from a point to a line. And the way we're going to do that is by drawing 3 circles. So this is our compass here, and we're going to draw a circle from the point, just so that the circle could intersect this line at 2 points. Doesn't matter how big the circle is, it just has to intersect the line at 2 points. So that's 1 circle. So, and now we can see that it intersected at this point and this point. Now what we need to do is draw 2 more circles of the same radius from these 2 points. Right here. So this is the same radius. That's 1 circle, and our second circle is this radius. As you can see, we have circles that are intersecting at 2 different points. Now, we can draw a straight line from here. Straight line. This is just to give us the basic straight line. And we have to make sure it actually hits the points. And, well, we can't see it perfectly because I'm not a perfect drawer, a perfect artist, but when you measure it with a contractor, you will see that this is a 90-degree angle. This happens with every circle, with any circle that intersects the line at 2 points, and with any point and any given line. I did another example earlier that shows the same exact thing. Here's our given line and the given point. I drew a circle here with the radius r and 2 other circles, and the line that intersects both points is perpendicular to this line when measured. So it happens in every circumstance. So we have now proven that between a dot and a line, there is a perpendicular line that intersects both. So we can look at here. In our problem, we had a point and a line, and we were able to draw a triangle from this point and line because we can draw a perpendicular line from this point that goes through this line, another perpendicular line that goes from this point through our x-axis, and one that goes from this point through our y-axis. And it creates 3 intersecting points of our triangle, the 3 vertices of our triangle. This is our given x1, y1, and our new point x1, because it is parallel to y-axis, it has the same x, and y2, a different y. In the same way, we have a new point here that is x2 and y1. Because it's parallel to the x-axis, it has the same y. Now we said that our distances is the absolute value of x1 minus x2, and the distance of this one is the absolute value of y1 minus y2. We used absolute value, which is the actual magnitude of numeric value. That is the definition of absolute value, and it's denoted as such, 2 lines going straight down. Now we know that the distance has to be y1 minus y2 because of these examples. If we have a point at 3 and another point at 1 on an axis, then we know that the distance is 3 minus 1. And absolute value of that is 2. As you can see, that absolute value is just these 2. We can also have it 1 minus 3, which is negative 2, and the absolute value of that would still be 2. It doesn't matter which one's minus. If you have absolute value, that's the distance. In the same way, we have here 1 minus negative 2, Or similarly, we can say 2, negative 2 minus 1, which is negative 3, but the absolute value of that is 3, as you can see. Here, you can see that the negative 1 minus negative 5, that equals negative 4, but our absolute value is 4. So that's how we found our distances between 2 points.